Hi everyone, this is Miss Jamison. Yesterday you looked at Miss Mackey's lesson on working with integers. Now today we're just kind of extend that into rational numbers. Now remember, rational numbers are everything besides the whole numbers and their opposites, but they also do include the whole numbers. So when we talk about rationals, usually we're talking about fractions and decimals that end and decimals that repeat, mixed numbers, improper fractions, all of that kind of stuff. But remember, integers can also be written as decimals, and they can be written as fractions, which means that they also are considered rational. So when we look at today's, we're going to have some integers also involved with other rational values. And because of that, here's the nice thing. Because an integer is a rational number, well, the rules for rational numbers, they're the same as for integers. So when we have the product of two numbers now, we're going to say rather than integers, with the same sign, their product is always going to be positive. And again, integers are rational numbers, so all numbers where two numbers are different signs, the product of those two numbers, well, it's going to be negative. And remember, products with lots of factors, and yes, even 3 can be considered lots of factors because it's more than 2. It means you have to do more than one set of multiplication. Well, how can we tell if the product will be positive or negative? Remember, it was if you have an odd number, it's negative. If you have an even number, it's positive. Now, when I say odd number and even number, I'm not talking about the actual numbers that are multiplying. I'm talking about how many do we have. So, if we have a positive and another positive, okay, same sign, they'd be positive. But if we now attach a negative in there, I've got an odd amount of numbers that are negative. 1. 1 is an odd number. That means that my product is going to be negative. Now, if I change just one of those and I say, I'm going to change this to be a negative, but I'm going to keep that a positive, and then I make that a negative, well, I have an even amount of negatives. There are 2 of them there. 2 is an even number. Then my answer is going to be positive. Now, I could add more positives and negatives in there, but as long as you've got an odd counting number, like 1, 3, 5, 7, 9, 11, 13, favorite number, then you're going to have a negative product. If you have an even amount, 2, 4, 6, 8, okay, of negatives, then you're going to have a positive. Guess what? That also works if you have 0 negatives, because 0, it's an even number, right? So, take a moment, pause the video, write this down. Okay, now we're back. After you've paused, let's talk about our visual reminders. Our first visual reminder was our little triangle. Triangle is awesome, but remember, it only works if you have 2 factors. If you have 2 factors, you cover up the signs of the 2. If you have 2 negative numbers, your product will be positive. If you have 1 negative and 1 positive, your product will be negative. And hey, it works if you go the other way. 1 positive, 1 negative, cover it up, and you're going to get a negative answer. Now, we don't have, hey, what if I cover up 2 positives? Because you guys have been doing that since 3rd grade. Everything you knew until this year was all about positives, so you don't have to worry about that. We also talked about our cute little number line that Addition and subtraction are all related. Remember, if you are adding a positive number, you just go to the right. If you're adding a negative number, you go to the left. And then we had our cute little guys. If you have Miss Parks, she was doing her little Pinocchio, remember, with his nose. And if you have Miss Mackey, she was doing her cute little monkey. Wasn't he adorable? And then if you were with me, we were talking about Tigger. And Tigger bouncing along on the number line. Now, since I'm teaching, I'm going to remind you about Tigger. So, when you're with Tigger, you always stand facing the positives. And if you're subtracting, okay, you turn around. And then you end up facing the negatives. Okay? But our first number, depending on what sign it is, you'll either walk forwards or you'll hop backwards. So if you were taking a positive and then you were subtracting a positive, okay, you would say, okay, I'm looking at the positive, I'm walking positive, but then when I subtract, I'm turning around. Oh, I'm subtracting a positive. I'm going to go forward. Look where it takes me. It takes me over here. Further negatives. And if I'm subtracting a negative number when I'm facing that way, I'm walking backwards. Ooh, I go into the positives. And so it kind of looks like, hey, they're the same. They're the same. Okay? And we talked about all of that fun stuff with same signs, add and keep, different signs, subtract. Take the sign of the bigger number, that will be exact. All right, so just some little fun stuff we had going on. And so when they were same signs, we just added them. When they were different signs, we just subtracted them. And then, because, well, multiplication, what made it so easy in the first place was it was repeated addition. And so at first some of you were like, oh, I can go 2 and 2 is 4, 4 and 2 are 6, and then eventually went, oh, 2 2s are 4, 2 3s are 6, or 3 2s are 6, and you did all of that. And so it's just repeated. Well, then the rules for addition work with multiplication. So when they were the same sign, they go that way. When they were different signs, they went this way. And so we have, if they're the same sign, you get a positive product. If they're different signs, you get a negative product. Now I know that's a lot to think about, but if you remember that subtraction undoes addition, but multiplication is the repeated addition, you can see how all of those things lead you that direction. Either you're walking that way or you're walking that way and you end up with a positive, or you're walking this way or you're walking this way, and all things lead to a negative. So these are just some things to help you out to remember, oh yeah, same signs are positive, different signs are negative. When I multiply, you're going to be awesome, right? And so whether you like to use the triangle, kind of cute, easy to cover up things that you're using, or think about it with the number line, because we remember subtraction was pretty easy with a number line. It was a little weird with tiles. So whichever one makes it easier for you, go for it. Go for it. Now today we're going to talk and remember about all the fun stuff of fractions. And yes, we love fractions. So you're going to have to just get used to that. And you're going to eventually love fractions as well. So when you multiply fractions, remember, fractions are parts of things. So if you're multiplying by a part, it's going to get smaller. It's not going to get bigger. And so that's some of the stuff from fourth grade, fifth grade, sixth grade. And if I sound like I'm channeling your fourth grade teacher, then so be it. So remember, you have a certain number of groups with a certain number of units per group. So you don't need a common denominator for multiplication. Yay! Not that the common denominators are hard, but that's one less thing that you have to do. You can just use your fractions and great. So it goes. So when we talk about 1/2 times 1/3, it really means 1/2 groups of 1/3. Yeah, I know, that seems really weird, right? Half the groups of a third. So just kind of a little picture, and I know these are yellow and may not show up too well on your screen, but this is 1/3 of the 2, okay? So I'm looking at 1/3 of the whole. Right there is 1/3 of the whole. If I cut that whole in half, I'm just slicing right down the middle. Suddenly, my third is cut in half. And I only want 1/2 of that. And so what I'm going to look at is right here, my part, my 1/2 of a third. And when I look at it compared to the whole, it's 1 part of 6. So 1/2 of 1/3 is 1 of 6 smaller pieces. And so how that works then is we can just multiply our numerators and then multiply our denominators. So this is just some stuff, basically some fourth grade models. And I know that you all did some of these kinds of pictures back in fourth grade. So if we look at these, and I suggest you write these down, when I multiply, usually the answers get bigger, but when I multiply fractions, the answers get smaller. And why? Remember, it's because you're taking a part of a part. You're multiplying a part of another part. So you're looking for a portion of that other portion. It's going to get smaller, all right? So when we multiply, and each of these are some different ones. First, I have 1/2 times a fourth, or a 1/2 of a fourth. Now, there's this weird little asterisk in there, or star, because quite frankly, if you're typing in Canvas and you need to try to do a raised dot, it doesn't exist. The only thing you can do is maybe type a little star, or you can type parentheses. And a lot of the stuff that we're going to do, you're going to see parentheses. These are either around 1 or around both. But this has got a little star, which says 1/2 times 1/4. This one, 1/3 times 1/2. And this one, 1/2 times 3/5. Now, if you look at these pictures, they are 4 parts, 2 parts, and 5 parts. I know that 5 part was a little tough to see because really you kind of have some white lines. So if you look at them, and then you can see that it really is split into 5 parts. That one's pretty obvious. This one may be a little tough. There's 1, 2, 3, 4 parts. Now, what happens if I take half of this fourth? If I take half of this fourth, I'm going to just take some scissors. Okay. Yeah, I know I make weird pictures of scissors here. So I'm going to take some scissors and I'm going to cut that in half. And when I cut that in half, here's this funny thing that happens. Slice it down the middle, and my fourth is now cut in half. But when I cut it in half, this one piece here, or this one piece there, is now 1 part of 8. So go. Half of 4th is 1 of 8, or 1/8. This one's a little trickier because it looks like 1/3 of a half. 1/3 of a half means I actually need to take my scissors and cut this into 3 equal sections. It's like if you got a piece of paper and you do the taco fold, or the burrito fold, so that it's, ooh, hey, that works great. So what happens is I'm going to cut that into 3 slices that way, and it looks like this. And if I take just one of those on this side, and it doesn't matter which one, I have 1 part out of the 6. Or I can say 1 times 1, 2 times 3. Everybody good? That one, that's easy. I already have fifths. I've got 3 of them shaded. And if I cut it in half, whoa, what happens when I cut it in half? Look at that. Now, half of 3/5, half of the 3/5 ends up being right here. I cut my 3/5 in half, but those are still already sliced, which means now I have 3 out of 10 sections. That kind of should be what you did in 4th grade. And if you remember it, yay. If you don't remember it, maybe this is a good little refresher. So this is why we come up with those, how do you multiply fractions and why does it work? So when we look at this, and I'm going to give you a moment to write these down. We have some sentences we're going to complete with 4 examples of what I'm talking about. And I'm going to give you a moment to put me on pause, freeze frame, and you write this stuff down. And we're back. All right, you've written this all down. Yay! All right, we're going to talk about what we're doing. So, to multiply just fractions, all I need to do is multiply across. Not in across. I'm not crossing them. I'm just going straight across. Straight across. So that is multiply across the top. Then the bottom. Okay. Top numerators, bottom denominators. Top are numerators, bottom are denominators. And then, of course, you would simplify if you can, right? If I'm multiplying a fraction and a whole number, I change the whole number to a fraction. Okay, I make it rational. This is something you're going to hear a lot in 8th grade, rational. Everything they do is about rational values and something irrational, but we won't talk about those. So we make it rational. And we do that by putting it over 1. So we put it over 1. That means that my 3 multiplying by 7/8 is really going to be 7/8 times 3 over 1. Remember, a fraction is division, and you don't want to change its value. So 3 divided by 1 is still going to be 3. It's got to stay equivalent. Remember that? That was an easy one. Okay. If I multiply with mixed numbers like this next one, 1 3/8 times 2/3, well, I need to change the mixed number to an improper fraction. And remember, an improper fraction is one where the numerator or the top number is bigger than the bottom number. And so on 1 3/8, I multiply 8 times 1, and then I add 3, and so I end up getting 11, but I keep my denominator 8. And then I'm going to have times 2/3. Okay? Every one of you should remember how to do those. Okay? Nothing strenuous, no big deal. It's just you got to have a fraction times a fraction. They have to be in the same form. They have to be in the same form. Kind of like when we did common denominators to add and subtract. We said you got to have things that are alike. Well, this is not that they're alike with denominators, but they look like they're the same kinds of things. They're both fractions. Now, some of you I know were taught some shortcuts. Some of you maybe not. Some of you might go, yeah, I kind of remember that. And others of you, what are you talking about? Now, this is a nifty little shortcut that will help you out. And the shortcut, depending on your teachers, you might have been told it was cross canceling, or they might have called it cross dividing. I do know a few of the elementary teachers who use that. Or you might have heard cross simplifying. Okay. I know you had teachers who used one of those kinds of ways of saying it, right? Cross canceling seems a little weird, but what you're doing is you're crossing the numbers out and canceling them out and replacing them with something else. Cross dividing, you're dividing two numbers by the same value. You're still going to cross them out and replace them with something else. Cross simplifying, remember, simplifying is finding a common factor, something that divides evenly into two numbers, and then changing them into those two numbers. So it sort of comes out the same way. The thing about it is it does end up with numbers that are not across from each other, but are kind of in a cross. Wow, I know. Across, cross. One word, across. Separate words, cross. Okay? So this is how this one worked. So when we're looking at 16 and 35, and we're looking at 15 and 4. Okay? What I'm really doing is some of my simplifying before I ever multiply. And the reason for that is because if I have to multiply 16 by 15, that means I got to take some extra time doing a multiplication. Same with 35 times 4, though you could probably multiply that one without too much trouble side to side. But 16 and 15, you're going to have to stack them and then get their product. But if I can make one or both of those numbers smaller, it's going to help me. And to do that, I want to think about, eventually these are going to be in the same fraction. And if they are, hey, if there's something here and something here that have the same factor, I can divide them. I'm going to do that before they actually are together. So I'm going to look at these numbers and say, I've got 16. I know it doesn't share anything with 35, but wait a minute. It shares a couple of things with 4. I can make both of those numbers smaller. Now, I can make them smaller in 2 different ways. They're both even, which means I could divide them both by 2. And yay, 8 times 15 is going to be a lot easier to multiply, and 2 times 35 is also going to be a lot easier to multiply. I just cut my work in half. Wow, what a concept. But they also divide by 4. 4 is their greatest common factor. 2 is their common factor. But remember, I don't care if you get the least denominator, if you get common denominator. I don't care if you get the greatest common factor or a common factor. It's going to make your life easier. And hey, easy is good. So I'm just going to show you with the greatest. If it's the greatest, I can look at 16 and 4 and say, you know what? I can divide them both by 4. And I'm going to do that. And when I do, I'm going to cross off those 2 numbers and write what I get when I divide them. So if I divide 4 by 4, it's going to fit in there 1 time. So I cross 4 off and replace it with 1. If I divide 16 by 4, I cross 16 off and 4 fits in there 4 times. I just made my work way easier. Look at this. I'll only have to times 35 by 1. Woo! How easy is that? But wait, look at that 35. 35 with 15? Oh my gosh, they can both be divided by 5. I'm going to do that. So if I divide them both by 5, 15 gets replaced with a 3, and 35 gets replaced with a 7. And oh my gosh, look at that. I've got multiplying I can do in my head because I know 3 times 4 and I know 7 times 1. I've just reduced my work to something really easy. And when I need to simplify it from an improper fraction, hey, I just made that work easier too because now I'm going to be dividing 12 by 7. Now, some of you might say, well, what if I only saw that 16 and 4 could be divided by 2? No worries. If you only see 16 and 4 as divisible by 2, well, guess what? You can say, hey, 4 divided by 2 is 2, 16 divided by 2 is 8. Like I said, you just made your work way easier. Now you could say, well, what if I didn't see that, but I saw 15 and 35? Guess what? That's okay too. Options. That's the fun thing about fractions. You can do all kinds of options. That's what makes fractions fun and easy. Besides, the real world runs on fractions, unless it's money. Money is decimal, but really out in the real world, not much else is decimal. So knowing fractions is an awesome thing to know. Alrighty, now we're going to put this to use. We're actually going to look at some problems. So we're going to find the products of a few. And we've got here 2 fractions. We have a mixed number with an integer, and we have a fraction with an integer. So go ahead, take a moment, write those 3 problems down on your paper, because you all know you should always have lots of paper and pencil. You should always be writing everything down. everything. Yay? Okay, take that moment. And we're back. Yay, you got those all written down. We are going to look at these two fractions right here. I have -1/2 times -4/5. Now remember, Miss Mackey talked to you about we don't always use a raised dot. Sometimes we use parentheses. And you're going to see parentheses around fractions more than you will the raised dot. They're just kind of weird that way. But we never at this point want to use an X, because X's are going to mean some other things, which some of you already know, but we don't want them to be an X. So I have these two fractions, and I can do just like we said on our previous page. I can just multiply straight across. Yay. I am going to multiply 1 times 4, and that will give me 4. I'm going to multiply 2 times 5, and that will give me 10. And woo, look at that, a negative and a negative. They're the same. So that means it's going to be a positive 4/10. But if I look at that 4/10, I think, wait a minute. I can't have an even number on top and on bottom. They can both be divided. So I'm going to divide them both by 2. All even numbers divide by 2. And when I do that, I end up with the fraction 2/5. And I say, yay, I'm good. Now I know some of you are thinking, Mrs. Jameson, why didn't you cancel it out or simplify it out? Guess what? You can. So if you look at that same problem, here's our OR. I have -1/2 multiplying by -4/5. And I say, well, wait a minute. 2 and 4 are even numbers. I'm going to divide by 2. I divide by 2, I get 1. I divide this by 2, and I get 2. What I just did here was what we do right there. I'm dividing the top and the bottom by 2. It's just they're one top, one bottom that are not necessarily in the same thing. But eventually, remember, they would end up being in the same thing. And so when I multiply now, I'm going to get 1 times 2 is 2, 1 times 5 is 5, and 2 negatives, the same sign, are going to be a positive. Yay! I don't care which way you go, you end up at the same point, and somewhere in there, you're dividing both parts by 2. Either once you've got here, numerator, denominator, or here, numerator and a denominator. Either way works. It's what works for you. Okay? Moving on. I have a mixed number. Oh yeah, mixed numbers. I gotta make them improper. So I'm going to take -1/2 and I'm going to change it up. I'm going to multiply and then I'm going to add. So 2 ones are 2, and 1 would be 3/2. But remember, they're still equivalent, so I haven't changed my sign. A negative unsimplified is a negative simplified. The other way around, a negative simplified is still a negative unsimplified. And then, oh my gosh, I've got an integer. I have -6. Remember, I need to turn it into a fraction, or its rational form. So I'm going to put it over 1. Yay. Now, again, options. I can just multiply and I can simplify. So if I just multiply them, I'm going to get 18 in the numerator, 2 in the denominator, negative and negative make it positive, and then It's an improper fraction. So 18 divided by 2 is 9. Or, hey, 2 and 6, look at those. They can divide by 2. I could make this 1 and this 3. And look at that. 3 times 3 is 9. 1 times 1 is 1. Negative and negative are positive. And oh my gosh, what's 9 divided by 1? It is 9. Oh, look at that. Now, do you have to cross cancel? No. Do you have to simplify? Yes. So whether you multiply and then simplify, or you simplify by canceling, either way is great. Now, careful. I have a 3 and a 6, but they're on the same level. You can't simplify on the same level. It's got to be top and bottom. Top and bottom. Remember, what happens to the top happens to the bottom. Not what happens to the top happens to the top. No. It's what happens to the top happens to the bottom. All right? We're going to do one more that is a fraction and an integer. And remember, I'm going to keep my fraction, but my integer I'm going to change into a fraction by putting it over 1. And again, you got options. You can multiply it and simplify it, or you can cross cancel it and simplify it. Now I know I'm going to have to simplify it because look at that 12. That 12 is big. That 12 is big. So it's going to definitely give me something I'm going to have to cancel because it's not going to get really small. So if I do the canceling, it's going to look like this. I can divide them both by 2, or I can divide them both by 4. If I divide by 4, that's a 1, that's a 3. I multiply my numerators, 3 3s are 9. I multiply my denominators, 1 1 is 1. Negative times positive means this is negative, but wait a minute, it is top heavy. So 9 divided by 1 is 9. And I didn't change its value. I just changed what it looked like. It stays a negative. We good? Awesome. All right. Now, remember, we're talking rationals, fractions, integers, but there's something else that's rational, and that other thing that's rational are decimals. Now, I know some of you really love you some decimals, and some of you are like, I hate decimals, but you got to do both decimals and fractions because numbers, they're all over the place. So we're going to look at some decimal values. All right, so we're going to complete first a sentence. I want you to write this down. And then we've got a couple of problems. We won't necessarily do all of them. We'll do a couple of them. I think we'll do number 1 and we'll do number 4. We'll do number 1 and number 4. So just write down number 1 and number 4. All right, for right now, I'm going to have you do 2 and 3 on your own. But for us together, we're going to do number 1 and number 4. So yeah, you will need 2 and 3 just because you're going to get to do them on your own. Okay? So I'm going to pause. You are. And you're going to write stuff down. So pause. And we're back. All right, so we're going to complete this first sentence. To multiply decimals, what could that be? Well, decimals are sort of like fractions, but we're not going to make numerator denominator. But they're a lot more like whole numbers. So I'm just going to multiply my decimals, my decimal values, okay? So to multiply decimals, I am going to have to stack and multiply. I am going to stack and multiply. Now you notice there was this other sentence here. I do not need to blank blank the decimals to multiply decimals. Okay? Now if you think about add and subtract, that was the first thing. Line up the decimals. Line them up to add. Line them up to subtract. We always put the bigger one on top. Now you can do that with the multiplication, put the bigger one on top, but you don't have to line up the decimals. So our blank are you do not have to line up the decimals to multiply them. Sometimes they do. Yay. Sometimes they don't. Yay. It doesn't matter. Woo! Because you take care of the decimal at the end of the problem. At the end of the problem. So we're going to just start with our first one, like I said. We're going to do 1 and 4, and I'm going to leave you to do 2 and 3 on your own. That's because 2 is kind of like 1, and 3 is kind of like 4. All right? But 4 could be a little sneaky. It's one of those sneaky ones if you wanted to look at it. All right, so first thing I'm going to do, I'm going to stack my numbers. And since I have 2 and 400ths, it's not bigger than 5, but it's longer than 5. I want to put my longer one on top. So I'm going to write 2 and 400ths. Now, if this were addition, I would have to put 5 under 2, but I'm not doing that. I'm multiplying. I'm looking for -5 groups of this. -5 groups of that. So I'm just going to multiply by 5. Now I know those of you who are in my class, when we added and subtracted, we always put the sign with the number. If you were with Miss McKay, or Mackey, sorry, or Miss Parks, you put the sign on afterwards. It doesn't matter, it's okay. But with multiplying, I'm not going to put the signs in because I don't want to suddenly say, oh, I'm subtracting. No, I'm not. Or I'm adding. No, I'm not. I'm not going to worry about the signs. I'm just going to worry about multiplying. So right now, this actually looks like what you did in 4th, 5th, and 6th grade. You have 2 and 400ths, and you're going to multiply it by 5. Now, when we multiply, we're going to not only ignore the signs, we're going to ignore that decimal. We're going to pretend it ain't even there. And we're just going to multiply by 5. So we know that 5 times 4 is 20. I put a 0, and I carry over the 2 into the next tens place. Well, 5 zeros, that's 0. So when I add 2, it's going to be 2. And then 5 times 2 will be 10. And I go, woohoo! I've got 1,020. Not really. I'm not multiplying 200 by 5. I'm multiplying 2 and a little bit by 5. So if I'm multiplying 2 times 5, it can't possibly be 1,000. It's going to be only 10. So it's 10 and 20 hundredths. Now, your teachers in elementary school told you this nifty little thing too of, hey, count how many are behind the decimal in the problem. 2 there, none here. And so then you move your decimal over that many. And look where it went, right behind the 10. Woo! Who would have thought? But it's an easy way of thinking about it. That 2 is a whole number, that 5 is a whole number. It better not be much bigger than 10. It can't be 100. It can't be 1,000. And then I look back and I say, whoa, wait a minute. I had a negative number in there. One negative number means that my solution is going to be negative. Now I know some of you are like, although I need the 0. If you're doing the work, yeah, you need the 0. If you type it into Canvas, yeah, you should probably put your 0 on there. But what if you let it fall off? Well, Canvas and Rise are kind of forgiving on end zeros. So if you let that fall off, you aren't really rounding. You're just saying it's an equivalent value. So if you put in Canvas -10 and 2/10, you know what? You're perfectly okay. Either one is a legitimate answer. But if you aren't told to round, don't you dare round. Don't you dare round unless you're told to round. Okay? Yay? All right. Now, 9 times 7 and 5/10. It's going to be the same as this one. Integer times a decimal value. Both of these are decimal values times decimal values. Now, this one, -3 and 25/100, I would just put as the top number. 4 and 8/10 is the bottom number, because if I put this on the bottom, I only do 2 rows of multiplication. If I put this one on the bottom, I do 3 rows of multiplication. I'll get the same answer, but hey, that on the bottom gives me a shorter problem, less work. My next one though, however, here's the thing. 3 and 8/10 multiplied by -2 and 1/10. When I put these there, it looks like they line up. Well, they kind of do anyway. But quite frankly, I really don't care that they line up. It's okay if they do. It's okay if they don't. I'm just going to pretend the decimal isn't there anyway. And so if the decimals aren't there, it's like 38 times 21. You all can do that. That's 3rd grade math. So we multiply 1 times 38, and we're going to get 38. Now I know I kind of skipped 1 times 8, 1 times 3, but hey, 1 times a number, it's the number. We still treat this like 20, and so we put our placeholder 0. You multiply by a multiple of 10, it's going to end in a 0. Then, hey, I'm multiplying by 2. Wow, that's pretty easy. 2 8s are 16. I carry my 1 over. 2 3s are 6, and the extra one is 7. Or, for those of you who are really, really good at your multiplication, hey, 2 times 38 is 76. Now, I don't expect y'all to know that, and that's okay. Some of you are there, some of you aren't, some of you are comfortable with that. Whatever floats your boat. We then are going to add these up, because remember, that's the next step. And we add just like regular whole number place value. So that would be 8, this would be 9, and that would be 7. Okay? Now, remember, what are we multiplying? Our whole number is 3, our whole number is 2. If I brought my decimal down, I would be saying 3 times 2 is 79? No way, that doesn't work. 3 times 2 can't be 79. That's why we don't drop it down. That's why we do the count, there's 1 space, count, there's 1 space. I'm going to count over 2 spaces, and I'm going to put it right there. That makes more sense. 2 times 3 is 6. I got 7. But remember, it's more than 3 and it's more than 2, so I should have more than 6. But I shouldn't have 79. That would be way too many. So these are just some things to remember about checking your decimal values. And hopefully that's kind of channeling your 4th, 5th, and 6th grade teachers. And don't forget, a positive times a negative means that this is going to be a -7 and 98/100. Yay? We're awesome? All right. So those two, you can put me on pause for a few minutes, do those 2 problems, come back to them, but you better make sure you do those two problems because you need the practice. And this is what this is, stuff to practice. All right? We're going to move on, though. We're going to look at a couple of word problems. So, yep, word problems are everywhere in 7th grade. Get used to it. We're going to talk word problems all year long. And guess what? You're going to have them in 8th grade and 9th grade and 10th grade and 11th grade. Actually, the whole rest of your life. Word problems are life. Okay? So, it's nothing to be afraid of. You can put me on pause for a minute while you write the problem down. And go. All right, you got that problem written down. We are going to talk about this, our cute little kids. It says there are 45 students in a PE class. Now, those of you that are here, you know that's about the size of your PE classes. Some are maybe a little bigger than that, but that's about the size they are. If 4/9 of the students are boys, how many students are boys? We're looking for that part of the whole class. So when you're looking for a part of a whole, you are looking for a multiplication of a fraction. So we can write this as we have 45 students in our class, and that's our whole, and we're going to take 4/9 of that class. Or you could kind of maybe write it as 4/9 of the class of 45. But guess what? It's the same two numbers. And if you remember, doesn't matter the order on multiplication or addition. It does on subtraction and division. So both of these will work for you. We'll talk later about what maybe should be the order and things like that. But for right now, we're looking for part of a whole. Part of a whole. That's a fraction times a whole number. Now, whether you do that one or you do this one, no big deal. One thing you're going to have to do is you're going to have to make sure that 45 becomes a fraction. And when 45 becomes a fraction, then everything works out wonderfully. You're putting it in its rational form. Now, you can do this problem two different ways. You can say, hey, 45 times 4. If I do 45 times 4, that is 180. And then 1 times 9 is 9. And then you have this kind of big improper fraction, but hey, that's okay. 180 divided by 9 is going to be 20. But some of you might have looked at that and said, well, Mrs. Jameson, that same problem, I can see that I've got two numbers that share something. They do. 45 is divisible by 9. It's really great if one of the numbers divides evenly into the other number, but you saw from the past that doesn't always happen. It does here. We can divide by 9 and say, well, 9 divided by itself is 1. 45 divided by 9 is 5. And then we can multiply and say, numerators, 5 4s are 20. Denominators, 1 1 is 1. And hey, 20 divided by 1 is 20. Look at that. They are equal. These two things are equal. They look just like each other. The pathways were a little different, but both ended up dividing by 9 at some point. Do we all see that? And then in answer to the question, how many students are boys? If you need to write, just fill in the blank, you could just write 20. If it's put your answer as a sentence, you would say 20 students are boys. If it's fill in the blank, you can put 20 or 20 boys if it asks for labeling. Read your questions. Always make sure you read how you need to answer it. Because sometimes if you don't read it, you might have something correct, but then you're missing out because you didn't follow the directions. All right, it's a big deal. Okay, we're going to do just one more. We're going to look at this one. Yep, decimal. You knew that was going to happen, right? So I'm going to have you pause it while you write this one about the baker and his cookies. All right, here we are. You're back, you unpaused, you've written that down, and we're going to look at our context. Remember, context is the words that tell you what's going on. So it says a baker needs to make 4.5 or 4.5 or 4 5/10 batches of cookies for a birthday party. We'll go with 4.5 because that's the fast, easy. If each batch requires 1.5 pounds of flour, that should say of. Oops, typo. Let's change that to an of instead of an or. How many pounds of flour will the baker need? I hope you all know that you got to have lots of flour for good cookies. That's what makes them soft and gushy. All right, so we look at this and we go, well, he needs to make 4.5 batches. All right, so 4.5 batches, and each batch, so every one of these needs 1.5 pounds. So I'm going to take this and multiply it by the 1.5. Everybody good? All right, so it's decimals, of course. We know we have to treat them like double-digit numbers. So we're just going to stack them. Don't worry about decimals lining up, even though they do on this problem. And we just multiply. So we're going to say, well, 5 times 5 is 25. And I carry over 2. 5 times 4 is 20. And those extra 2 would be 22. Now I'm going to multiply by this one, which is like the 1 in 15, which would be 10. So I'm going to put a placeholder because anything times 10, you can just write it and put a 0 on the end. And actually, that's what we're going to do because 1 times 45 is 45. So if I'm treating this like 10 and 45, that's 450. Now, I'm just going to add these because that's what we do, because they're now the same place values. We'll get 5, 7, and 6. And however you want to look at this, do I count how many are behind the decimal? There's 1, there's 1. So this one has to have 2. Or do I look at it and say, you know what? I'm multiplying a little more than 4 by a little more than 1. 4 times 1 is 4. I should have just a little more than 4. And hey, 6 is a little more than 4. Easy peasy. Way to double check what you're doing. And then if you're answering the question, it would be, he will need 6 7/75, or 6.75 pounds of flour. And there you have it. So rationals are integers, decimals that terminate, decimals that repeat, and fractions, mixed numbers, Okay, all of that. And you now know how to multiply them. And you know that if you have two of the same sign, it's positive. Two of different signs, it's negative. And if you're multiplying more than two factors, you count up the negatives. If you have an odd number, 1, 3, 5, 7, 9, 11, 13, then it's going to be negative. If you have an even amount of negatives, 0, 2, 4, 6, 8, 10, 12. Oh, I have to skip over 14. Hey, yeah, it's possible to multiply that many numbers together. Though, quite frankly, at that point, it'd probably be good to get a calculator out. But depends on how big they are. It's going to be an even amount. You're going to get a positive. So, here's for this. There are some more on our class notes. Remember, look at the class notes, take notes on the class notes, make sure you're writing these down, make sure you're looking at them as you do your lessons, but not your PCs. And we'll be seeing you. Bye.